Okay, so today we are doing the Module 12 discussion. So it starts off by telling us that we're going to be testing the null hypothesis that beta equals 0. So for the hypothesis test involving the discussions 1 through 10, we're going to show all 5 steps of the procedure. So first step, state the null hypothesis. It is beta equals 0. The conditions of having a linear relationship between x and y, independence, being normal, having equal variance, and a random sample are all met, so I will be using the linear regression model to understand this inference. To find the t-test statistic, I will be using the degrees of freedom and the 95% confidence interval to find the answer on a t-test table. So I found the degrees of freedom to be 78 because there were 80 results, and the t-test statistic to be 3.99 rounded. I then plugged that into the 95% interval for confidence interval equation, and I used the coefficient and the standard error for that. And I got the confidence interval from 0.19 to 0.57 and a p-value of 0.00015. So in this case, I decided to reject the null hypothesis. This is for the actual x values. For the intercept, I found the t-test statistic to be 4.313, and then I plugged that into the same type of equation and found that confidence interval to be between 17.74 and 48.2, and I also reject the null hypothesis. In this case, the p-value is 4.66 times 10 to the negative fifth. So I reject the null hypothesis that beta equals 0, and we're not given an alternative hypothesis in this case, but I would next want to probably accept that, but yes, I reject it. Okay, so then for the other two, I just did steps 3 to 5, so I have most of it written out again. Degrees of freedom were 78 for all of them. I have the t-test stat for the x values in that equation. It was between 0.69 and 1.02. And I found the p-value to be 3.7 times 10 to the negative 16th, and I rejected that null hypothesis. The 95% interval for the intercept, I found the t-stat to be 1.2, and I found that to be between negative 4.98 and 19.9, and a p-value of 0.237. So in this case, I actually failed to reject the null hypothesis with the intercept, with quizzes 1 through 10. Okay, for the third one, again, same degrees of freedom. This time there was a t-stat of 9.55, plugged it in and found it between 0.65 and 0.99, with a p-value of 9.15 times 10 to the negative 15th, so I rejected the null hypothesis for the x variables. But then for the intercept, I found the t-stat, to be 0.759, and I plugged that in to find negative 7.64 to 17.05 for the confidence interval, and I failed to reject the null hypothesis, so the p-value was 0.45. So what does this tell us? Well, in the exams 1 through 3 and the quizzes 1 through 10, we found that both intercepts failed to reject the null hypothesis, whereas with the discussions, it rejected it. So I think this will be useful later. Okay, so next up on the directions. Okay. So, yes. So now from this earlier page, which I think it was on here. Sorry, I'm just trying to get the right one. Oh yeah, so I decided to do the, I did the quizzes and the exams 1 through 3 on the first one. So I used that, and I found the r-squared values. But anyway, sorry, on the last page, we have the multiple regression lines. I found the intercept for the 95% confidence interval between negative 14.4 and 14.95. So I failed to reject the null hypothesis with that. For quizzes 1 through 10, I failed to reject the hypothesis again, And for discussions 1 through 10 and for exams 1 through 3, I rejected it. So this shows again how discussions 1 through 10 were not a good predictor of exam 4 because they could not agree with that. Yes, sorry. Anyway, so now we're going to look at the R-squared values from those confidence intervals that I talked about earlier. So in this case, it was quizzes 1 through 10 and exam 1 through 3, which in this case, for this one, I found the confidence interval. Sorry, this is over here. So I did quizzes, so it was this one. So I found the t-stat for the intercept to be 1.2 and the for the variable 10.3, and then the confidence interval for the intercept was between negative 4.9 and 19.9, and then the p-value was 0.24. So again, I was able to actually I failed to reject the null hypothesis with the intercept of the quizzes versus the exams 1 through 3 just by itself. And then looking at the multiple coefficient area, we already looked at those, but we're also going to look at the change in R-squared values. We're going to go to this other thing that I actually used last time. So the R-squared of the quizzes, which is just this single graph, which I just talked about, is found to be 0.3229. Then the R-squared of the quizzes and the exams 1 through 3 was 0.54. Then that minus those two numbers subtract from each other, 0.2166. And then R-squared of quizzes 1 through 10, exams 1 through 3 as base against exam 4, minus the R-squared of just quizzes 1 through 10 and exams 1 through 3 is 0.03. So that's the difference in R-squared values. Those three equations are again found here. Okay, so then let's talk about the discussion. So basically we found that in every data set that I used, the discussions, you could not fail to reject the null hypothesis. You rejected it in every one. So that basically means that even the intercept, it didn't really tell you anything about the actual exams 1 through 3. It was not a good predictor. However, it does not necessarily mean that performance on earlier exams is the best predictor either. It could also mean that the quizzes were a great predictor, and as I already studied them before, I can find that they're a good predictor. And I would say that, like, again, this is not causation, like, oh, this means this, so then this means exams must be great. It's more of a correlation. It could mean that, but it doesn't necessarily mean that. So, yeah, I think it could be either the exams or the quizzes, not necessarily just one of them. So, yeah, that's my video and all my data, and I also used some data analysis from Excel to help me with my other things. So, thank you for watching.